Hello. Last topic in chapter 3, linear inequalities in two variables. So an inequality is one of the ones with like a less than or equal to instead of an equal sign. And this is a little different than anything we've seen so far, so bear with me. So it's like that. We've seen inequalities, but this one has two variables. It has an x and a y. So just like, with an equation in two variables, there's going to be a pair of numbers that satisfies these. But in this case, just like before, there's going to be infinite pairs of numbers for x and y that satisfy these. They just look a little different because it's an inequality. So it's like ax plus by is greater than c or less than or equal to c or whatever. So any of those four possibilities. Okay, so we talk about like a solution set to this. There's obviously not just one number for x and one number for y for which one of these is going to be true. So they're not hard to actually do, but like I said, it's just kind of new. So here's an example for the inequality x plus 3y is less than 6. So we want to find every single ordered pair that satisfies that. And here just randomly, here's a solution. So I just want you to see what constitutes a solution. So negative 5, 3 works because, okay, negative 5 plus 3 times 3 is negative 5 plus 9, which is 4. And that works because that's less than 6. Okay, so obviously there's an infinite number of other ones that work. But here's one that doesn't work. 1, 2 is not a solution because 1 plus 3 times 2 is 7, which is bigger than 6. So what you'll find is if you look at that x plus 3y is less than 6. If you just make that x plus 3y equals 6, that's a linear equation. Okay, and when we want to graph the solution, what we're going to do, you're going to find is we have a boundary line, which is just the line I just talked about, x plus 3y equals 6. And all of the ordered pairs that satisfy the inequality are going to sit on one side of that line. Okay. So what we do is we take that x plus 3y is less than 6, and we just replace the less than sign with an equal sign. Now that's a line. X plus 3y equals 6. So you can graph x plus 3y equals 6 however you want. It would be very easy to graph using the intercepts, or plug in 0 for x and then 0 for y, or you could just solve it for y and get the slope and get it in slope intercept form, whatever you want to do, but that's it. So you draw that on the graph. So you just imagine that it's x plus 3y equals 6, and you sketch that line. So this is kind of important. It's a dashed line. I made it dashed, and I did that for a reason, because this inequality is not inclusive. So actually when x plus 3y equals 6, that's actually not a solution. Right? So any number that sits on that line actually doesn't satisfy the inequality because of that it's not or equal to. So because it's not inclusive. So if it were, like the next example will be, we'll draw that as a solid line to indicate that points on the line actually work. Okay, so let's just graph the 2 points we said, one of which works and one of which doesn't. So negative 5, 3 lies below the line and 1, 2 lies above it. And we said negative 5, 3 works and 1, 2 doesn't. Really, it's as simple as that. The fact that negative 5, 3 is below the line means that every point below the line, so we're just going to use the words below and above, even though you could kind of think of it as being to the left of the line. Every single point down here below the line is a solution to the inequality. So that's it. So all you need for these is to draw the line, pick any test point, just guess a point, and we'll see what a nice point to guess is. And then you're just going to take your pencil and shade in this region, the region that in this case is below the line. And really, like I said, it's weird, but the only way to get that is just to kind of guess a point. Okay, so we just pick a single test point, and we want to see, so it's going to be one side of this boundary or the other that gets shaded in, and the test point just tells us which side we shaded in. We're done. Okay, let's just do an example. So we're going to graph this inequality. 2x minus 5y is less than or equal to 10. So that's by graph that we are going to draw shade in a plane region where everything in that plane region is true, satisfies this inequality. Okay, so that's the first step one. So this is just basically a two-step process. We graph the line 2x minus 5y equals 10. Pretty easy to do if you use the intercepts in this case. When, let's see, y is 0, we have 2x equals 10, so x is 5. And when x is 0, we have negative 5y equals 10, so y is negative 2. Boom. Right, the y-intercept is when x is 0. So there it is. And then the x-intercept is when y is 0. So there it is. So if you have it like this, see, it's very nice when these two coefficients are, when 10 is divisible by these numbers, because then it's super easy to graph using the intercepts. So in this case, that was the quick way to do it. Okay, so then just draw the line. Now it's a solid line because we're including points that actually sit on the line because this is less than or equal to. See the difference? Seems minor, but stuff like that is important. Okay, so that's the difference. So now we just have to guess any, we just need one point to pick. So what's like a super simple point to plug stuff in for? What number do we love to plug into equations? We like to plug 0 into equations, don't we, folks? So in general, I mean, you don't have to, but the easiest point to pick is the origin, right? Because plug 0, 0 into this original inequality. You can just do it in your head. 0 minus 0. Is that less than 10? It is actually, right? So, like I said, you could pick any point you want, but we might as well keep this simple. So let's just pick the origin. That works, right? So since the origin is here in the upper half, the upper region of the plane, everything in the upper region of the plane works. Every single point that's up here is going to work. So you shade it in, and my shading job is not great, but neither does yours have to be. But all I'm looking for is the line, whether it's solid or dashed, and then just which you're going to shade in one side or the other. And that's it. Just make sure it's the right side. And you know, you could pick a point down here too if you wanted, pick 4, negative 4 or whatever and plug it in. You'll see that it doesn't work. You can go ahead and pick some other random point up here, pick 2, 2, and verify that that works as well. Okay. Okay, let's do one quick application. For an elementary school fundraiser, a student earns 5 points for each magazine subscription he sells and 2 points for each novelty. A novelty is just like I don't know, some kind of trinket. He wants an MP3 player. Is that still a thing? That takes 40 points, or it costs 40 points, I guess I should say. So, let's think about that. He doesn't want to earn exactly 40 points, although that would work. He probably wants to earn more than 40 points. So he wants to see what kind of combinations of magazine subscriptions and novelties he could sell to make his, to make his commission there and get his 40 plus points. Okay, so we're gonna write by graph. Graphing is the same thing as solving in this case, except to draw the solution is a picture because the solution is a plane region. There's no really other way to depict the solution. Okay, so it doesn't really matter. You could call them, S and N or whatever, but we're just going to let X be the subscriptions he sells and Y be the novelties he sells. So he earns 5 points for each X, so that's 5X, and then plus he's going to earn 2 points for each novelty, so that's 2Y, and he wants that quantity to be bigger than or equal to 40, right? 40 would do it, so it's bigger than or equal to. Okay, so 40 or more translates to greater than or equal to 40. Okay, so here we go. So pretend that's an equal sign. Graph 5x plus 2y equals 40. Once again, easy to do with the intercepts. When x is 0, y is 20. When y is 0, x is 8. See where I got that? And then, when you're graphing stuff like this, so this is important. obviously just the line 5x plus 2y equals 40 goes everywhere. It takes on negative quantities, and x and y can be negative. But in this problem, it doesn't. It doesn't make any sense for x or y to be negative. And it certainly doesn't make any sense for 5x plus 2y to be negative, because then he'd get negative points. Okay, so when we graph it, and you don't, like, if on a calculator, you probably don't know how to do that. In fact, I don't know off the top of my head. But like that, on a computer, it's easy. We don't want our line to go up here or down here. And once again, I know that sounds fussy, but it's right for the problem. So it'd be wrong if you had the number going back here, because then you'd be saying the dude sells negative magazine subscriptions. Makes no sense. Okay, so this is the line 5x plus 2y equals 40, but it's just in the first quadrant. And we've seen that before. A lot of real world problems only make sense in the first quadrant. Right, so think about it reasonably. I mean, the stuff that's above the line out here is more. These numbers are bigger. This is the number 10, 20. And you get the feeling if he sold, what, 10 of X and 20 of Y, he'd probably make it, right? Whereas, okay, well, the number 0, 0 is right here. So if he sells nothing, it's obviously not going to make it. Okay, so really you can jump right to the fact that, okay, it's all this stuff out here. But go ahead and plug 0, 0 in. Is 0 plus 0 greater than 40? Nah. So it's got to be the stuff out here. Right, and that's the nice thing about 0, 0 is you can more or less do it in your head, although I would like to see you plug it in when you're showing your work on the test. So there you go. The solution is anywhere above here. So he could go absolutely ape and sell, 100 of these and 100 of these, and he'd obviously make it. But really anywhere on or above the line. So like right here, you see the point 4, 10 is on the line. If he did that, is that right? Yeah, he would, just barely make it. Is that right? 4 of x is 20. Yeah, exactly. Yep. Okay, so, your shade job doesn't have to be great. Mine certainly isn't. Just shade in the proper region of the plane. And then, like I said, don't shade in down here because it makes no sense for this problem. And that's it. That's the solution to a linear inequality, is this picture. Okay? Thank you.